Hello, today we're gonna do Trig because I have a Trig investigation, like Trig practice, I guess. It's a good title. Alright. Question 1. Given that P is a non-zero constant and sec theta plus tan theta equals P, prove algebraically that cosecant theta equals P squared plus 1, P squared minus 1. So we're gonna do prove. So right hand side equals plus 1 p squared minus 1. That equals to sec theta plus tan theta squared plus 1 sec sec theta plus tan theta squared minus 1. And that just equals to, because we know that tan theta plus 1 tan theta squared plus 1 equals sec squared theta. That means what we can do is we can just start expanding theta plus, because I have a plus 1, so might as well just use the tan squared. It's plus 2 sec theta tan, because that's expanding, plus tan squared theta plus 1. And on the bottom, we'll write, because minus 1, so if it's minus on this side, minus 1 on this side, it becomes tan theta, tan squared theta. So what we can do is this, we put 10 in the front, and then sec theta squared minus 1. And then what we can get is 2 sec theta squared plus 2 sec theta tan theta, because the sec theta, the sec squared theta came from here, and we can add it, so it becomes 2. On the bottom, this becomes tan, so we can do 2 tan squared theta plus 2 sec theta tan theta. And then the 2's cancel out, so it becomes sec squared theta plus sec theta tan theta over tan squared theta plus sec theta tan theta. So we definitely factorize something out of here, so we take out sec theta, it becomes sec theta plus tan theta. On the bottom we put tan theta out, so that becomes tan theta plus sec theta, and then these two can cancel out. So we'll get sec theta over tan theta, and that's literally 1 over cos theta over sine theta over cos theta. And we can times sine cos on both sides, and we will get 1 over sine theta, which equals to cosec theta, which equals to right. Oh, I think left hand side. Let's see if it's right. It's indeed the left hand side is cosec, so we're right. Now we move on to the second question. That wasn't that hard. Like normal proofs, I don't know why it's so easy. Okay, I don't know. Easy and practice for not getting it wrong in the test. Ooh. Okay, so it's a solve. So solve x plus cot x equals square root 3, and what we have to do, and then it's negative pi x pi. That means, so we start rearranging. For these, I think I'll just expand them into their actual things because it's kind of weird. That's just over sine x plus cos x over sine x equals square root 3. So then we can put that on the bottom. So plus cos x sine x equals square root 3. And what we can do is we can times sine to this side, so that becomes square root 3 plus cos x equals square root 3 sine x. So now what we have to do is that we have to use auxiliary angle, because there's a cos and a sine that are adding each other. and the x is common, so we can't use product sum to product. So that's that. So that becomes also we move cost to this side, but then move cost to here. But then we want to move that to the left side, so it's just square root 3 sine x minus cos x, because this side more important, just equals square root 3. And then we use our auxiliary angle, so that's square root 3 squared plus 1 squared sine x, because there's minus on the inside, tan negative 1b over a, and equals square root 3. And this is just 3 plus 1, which is 4. Square root 4 is 2 sine, no, that's the wrong bracket here, sine x minus, well, we know that tan 30 is 1 over square root 3. 30 is pi on 6. 3, and then we put the 2 on that side. These should, yeah, sine x minus square root pi over 6 equals square root 3 on 2. And because of the range, I mean the domain is kind of small, I'm not going to write the general equations, so because the value is positive and pi divided minus 6, pi on 6 is kind of small, so it's probably the two solutions on the positive side. So that's just, well, that's 60 is pi on 3 and 2 pi on 3. And so basically we'll make them to 6's, so that's 6, 2, 6, 4. Because it's minus, we're adding, so that means x must equal to 2 plus pi on 6 and 4 pi on 6 plus pi on 6. And that makes it so that x equals 3 pi on 6, which is pi on 2, and also 5 pi on 6. I think that's all the solutions, because if it's on the negative side, it won't make sense because this is positive, and pi on 6 is kind of small, and it's adding. So if it's adding, the only possible is the biggest negative. The biggest negative will be one rotation less, so it's a lot. So basically we have taken this one and this one, but we can't take this one because that would just be negative for this anyways, so we'll have to go all the way here. That's like negative almost 2 pi, which is impossible that to be in negative pi and pi, so these two must be the only answers. Oh well, that's it for the questions. Bye bye. Hopefully I find more difficult ones later for the next video on trig practice.